All right, so far we did find the kernel and image of boundary 1, but we could also quickly find the image, or sorry, the kernel of boundary 0. So look back at what boundary 0 does. Boundary 0 goes from the span of x, y, z, w to 0. In other words, the kernel is the entire thing. In other words, finding the boundary of a point always gives you 0. So now we're ready for step 4. At least one of step 4. We're going to come back and find more homology groups, but first we'll go ahead and find H0, the 0th homology group. So that's H0 is defined as kernel of boundary 0 modded out by the image of boundary 1. So you could write that as the span of x, y, z, w. That's the whole, the entire 0 chains, all of the 0 chains. That's always going to happen. Kernel of boundary 0 is always all of it. And then you mod out by the span of what we found just above, the image of boundary 1. I wrote it as z minus x and z minus y. All right, now we're back to reasoning out what that group presentation means. So we write x, y, z, w as the generators, and the relations are z equals x and z equals y. I could have written z minus x equals 0 and z minus y equals 0, like we saw just above, but I went ahead and went z equals x and z equals y. But that means I really only have 2 generators. X, since it's the same as z, and w. We also have that y is the same as z, so x, y, and z are all the same generator. And then there are no more relations, so just x and w. All right, next we'll go on to boundary 2.